Hey guys, it's Miss Wilkie, and today we're going over lesson 3.5, which is the lesson about slope. You should know most of this from last year. It should be a nice little review, but we're going to go over it to make sure that we are all on the same page. So slope is a couple different things, different ways you can say it. First of all, it's rise over run, so it's how much it's going up or down and then to the right. So it says rise, it could also be going down. The slope is the steepness of a line. So the steepness is like how fast it's going up. So is it just kind of flat or is it going up at a fast rate? There's several different formulas that we have for this. Usually M is our letter for slope. So slope equals, it could be rise over run like we were just looking at. Or it can be our change in the y values over the change in your x values. And another way to write this, instead of writing out change, you can just draw a little triangle, which means delta, which means change. So delta y over delta x. And then our last formula, which is the one you'll see the most, is using coordinates. So it'd be your y2 minus your y1, and then x2 minus x1. And then last thing, slope is the rate of change. So a couple examples for you here, like the speed limit, miles per hour, that would be a slope. So miles per hour, or if you're looking at miles per gallon, like how much you can get out of a gallon of gas, pretty much anything that has per in it. So cost per item, feet per second, anything like that. All right, let's look at this little picture up here. It's showing us our 4 different kinds of slopes. First one is positive because it's going up. The second one over here is negative because it's going down. If your line is flat, your slope is going to be 0. And if your line is going up and down, it's called undefined. So if you want to finish writing out that word right there, undefined. All right, so we're going to talk a little bit more about what a line looks like and what the different parts of it are when it's going either straight left and right or if it's going up and down. So we got our 2 acronyms here. We've got HOI and VUX. The first one is for our horizontal lines. The second one's for our vertical lines. And we can write out our information over here off to the side. The first row gives us the direction. The second row tells us the slope. And then that last row is going to give us the equation. So let's start with HOI. The H, like we just said, stands for horizontal. So that means your line is going left to right. The 0 is your slope, so it's 0 slope. And then the y, that's your equation. So your equation is going to be y equals any number. And then for VUX, the V stands for vertical. So that means your line is going up and down. The U, like we just talked about earlier, is undefined slope. So that means it doesn't exist. It's not that it's 0, it's just it does not have a slope. And then the last one is our equation, x equals a number, and it can be any number. All right, let's do some practice problems. On these problems, we are looking for the slope. We know that because it says m equals, and m is our slope. So the first one, if we look at the line, this line is going up and down. Now, if it's ever going up and down or left and right, you need to be thinking of HOI and VUX. So this line is vertical, so I'm going to write out over here that it is VUX. And then our slope is that second letter, so our slope is undefined. All right, next one, it is going up on this one, so that means it's going to be a positive slope. And for this, we can just count boxes. So you want to find 2 points anywhere on that line that perfectly line up with those grid lines behind it. So like these 2 points will work great. And then you're going to see how many it goes either up or down, and then how many it goes to the right. So when we're counting these right here, this one goes up 1, 2, and then it goes over 1. So it went up 2 and to the right 1. So when we write that out, it would be 2 over 1, which simplifies to just 2. So our slope on that one is 2. Next one, this line is going down, so our slope will be negative. So if you want to go ahead and write your negative sign, you can. And then we're using that same process. Find any 2 points on the line that perfectly match with the grid lines behind it. And then we're going to count how many squares it goes either up or down and how many it goes to the right. So this one's actually pretty easy. It only goes down 1 and it goes to the right 1. So our fraction would be 1 over 1, and that simplifies to just 1. And then our last one here, it's going left to right. It is a flat line. So we want to go back to Hoy and Bucks. This line is a horizontal line. So we're looking at Hoy, and that middle letter tells you the slope. So our slope here is 0. All right, next part, we're finding the slope from some other types of information. So this first one is a table, and our formula is right down here in this little star looking thing. That's our formula. So from this table, we've got 4 different coordinates. We do not need all 4 of them. You only need 2, and you get to pick which 2. It does not matter which ones. Usually we'll tell you to find which ones look the easiest to you. On this one here, I'm just going to go with the first 2 because why not? We want to label them first. So since this top row says X, I'm going to call this X1, and I'm going to call this one over here X2. And that means the bottom row, it's already labeled Y, so we're going to make them Y1 and Y2. Now make sure that your numbers are together. So see how I have the 1s on the left column and the 2s are together on the right column. So you don't want to mess that up. Make sure you're labeling them correctly. All right, so now we can go ahead and plug it in. So for Y2, that's what's coming first. We put -2. So -2 minus Y1, which also happens to be -2. Over X2, which is 2, minus X1, which is 1. So there's our equation. We would just type that straight into the calculator so that we don't worry about messing it up. And then when we type it in, it would tell us that the slope is 0. All right, next one, same concept. They just gave us the 2 points this time instead of a table. So you just plug it straight into the formula we're using. We're going to go ahead and label first again. Remember when they're written as coordinates, it's always an X and a Y. And this is our first set, so it's going to be 1s on both of them. And then the other set is still X and Y, but it's the second set, so they're going to be 2s. And then we can go ahead and plug this in. So again, our formula is over there on the left. So it starts with Y2. The Y2 is 3 minus Y1 is 11 over X2 is -1 minus X1 is -3. And if we were to go put this in the calculator, they would tell us that it is -4. So our slope between these 2 points is -4. All right, this last one here, they give us an equation. Sometimes they're nice and they'll put the equation in a format that you can clearly see the slope. This one is not the case. So in this one here, we need to solve for y, because once you have it solved for y, you can easily find your slope. So we want to get this y right here by itself, so we need to move everything else. Start with what's furthest from the y, which is this 3x. We're doing the opposite to move it, so we're going to subtract 3x on both sides. So 3x minus 3x makes 0. We can cross that off. Bring down the -2y. -10 and -3x do not have the same variable. The 10 does not have anything with it. The 3 has the x, so we cannot combine those. We got to leave them separate. So we're going to do -3x minus 10. All right, last step, we still want y by itself. We need to get rid of the -2 at the front. Since it is attached to your y, you need to divide by it. Everything gets divided by that -2. So that's going to leave us with, those -2's cancel out, which leaves us with y. We've got -3x over -2. That doesn't divide nicely, so we're just going to leave it as a fraction. We're going to clean it up a little bit, though. Those 2 negatives cancel out, so it's going to be 3 over 2, and you can put your x on the outside since it was on the top. And the last part, -2 divided by -10 divided by -2 is going to give us a positive 5. So plus 5 at the end. All right, last step here, we're still looking for the slope. When you have solved for y, the slope is whatever number is in front of your x. So right here in front of your x, is 3 over 2, so we're saying the slope is 3 over 2. All right, on the back side of the page, they want us to sketch a graph of a line that has a slope equal to 0. So again, this is one of our special ones. Since the slope is 0, we're thinking of either Hoy or Vux. Hoy is the one that has the 0 in it. So we're using Hoy here. And that first letter tells you if it's either horizontal or vertical. We've got an H here, so that means it's horizontal, which means it's going from left to right. Now, that's the only information they told us here, so it doesn't matter where on this graph your line goes. It just needs to be a horizontal line. So there's an option right there. Or you can draw it wherever you want to, as long as it's going left to right. And on this last section here, we're looking at parallel lines and perpendicular lines. For both of these, you find this information from looking at their slope. So we're going to be using the information we're just talking about. For parallel lines, they have to have the same slope. So both lines have to have the exact same slope. So this example here says, write the equation of a line that has the same slope as y equals 3x plus 2. Earlier we talked about the number in front of your x has to be your slope. So the slope here is going to be 3. And they want us to write an equation that has that same slope. So we want an equation that's parallel. Okay, so on this one right here, we can write anything we want to. The 3 has to stay there, though, because we want the same slope in order for it to be parallel. And then that last part, you can put whatever number you want to, either plus or minus, or you could even just leave the rest blank. It's up to you. I'm going to change it up a little bit, and I'm going to put minus 4. As long as that 3 is still in front of your x, then you are correct. All right, second part, perpendicular lines. This one's a little bit different. It does not have the same slope. Your slopes are going to be opposite reciprocals. Now, I know those two are big words, so we're going to go over them a little bit more. Opposite means that their signs are different. So that means one of them has to be positive and one of them has to be negative. It doesn't matter which one's which, you just have to have two different signs. Now, reciprocal, this means you are flipping the fraction. So I'm going to write this out, flipping the fraction. So basically, if you start off with something like 3 over 6, when you flip it, these two numbers switch. So it becomes 6 over 3. Next part says find the perpendicular slope for each of the following. So first one, negative 3. That one's already negative, so we know our second slope has to be positive because the signs have to be different. And then it says we also need to flip the fraction. So if you look at this technically isn't a fraction because it's just a negative 3. We need to make it into a fraction, though. We do that by putting a 1 underneath. Always, always, always put a 1 underneath. So now we can flip it. That means the 1's going to go on top, the 3 is going to go on the bottom. And like we said, it needs to be positive because the negative 3 was already negative. All right, next one, 1/2. Right now this is positive, so we know our next one has to be negative. They've got to be different. And then we're flipping it, so it's going to be 2 over 1. And we always want to simplify. Anything divided by 1, you can just take that 1 off of the bottom. So this could be negative 2. All right, last one, negative 4 over 5. This is negative, so our second slope is going to be positive. And we're going to need to flip them, so it's going to become 5 over 4. All right, last part here says circle the correct underlined word for each statement. So first statement says horizontal lines are parallel or perpendicular to the x-axis. So you probably want to draw a picture here. I'm going to go ahead and draw a graph. The one going left to right is the x-axis right here. And they're talking about horizontal lines. So that means it's the lines going from left to right. So there's an example there. So we're looking at that line I just drew. And we are looking at this line right here, the x-axis. Those two lines are going in the same direction, so that's telling us that those two lines are parallel. So parallel is your correct answer here. The second statement says vertical lines are parallel to the x-axis or the y-axis. So again, we're going to draw a picture here so we know what's going on. They're talking about vertical lines, so this time we're looking at a line going up and down. And they want it parallel, so we're looking for the line that's going in the same direction. So that's going to be this line going up and down here. The line going up and down is always your y-axis. So our answer here, vertical lines are parallel to the y-axis. All right, guys, I hope y'all have a great day. If y'all have any questions on these notes, please ask your geometry teacher. Bye, guys.